Hello all, in today's lecture we are going to study about canonical logic forms. What do you mean by the term canonical? Canonical meaning, say for example, let me take an expression like f of a, b, comma c is equal to a c bar plus ac plus ab. Fine. This is called a non-canonical standard. Why? Because how many variables are there in this equation? We have altogether three variables. What are the variables? A, B and C. These are the three variables. Here in an expression, every single min term. How many min terms are here? We have got three min terms. Every min term should have all the three variables in it. Only then that expression is called a standard canonical form. Here, when you see what variable is missing here, in the first term, B is missing. In the second term, again, B is missing. In the third term, which variable is missing? C is missing. If we have some missing elements in the min term, then it is called non-canonical form. Canonical meaning every single min term in that expression should have all the three variables in it. Only then that expression is called a canonical standard form. I'll give you another example. Let me take f of a comma b. This is equal to ab plus a bar b. Is this a canonical form or a non-canonical form? This is a canonical form. Why? Because this expression has got only two min terms and both the min terms are having the input variables. Whatever input variable is here given in the question, here we have got only two input variables and both the variables are present in your min term, either in the standard form or in complemented form, that doesn't matter, but the variable has to be there in the expression in the min term. Only then that expression is called a canonical standard form. Is that clear? Now, I'll give you another example. Tell me whether this is a canonical or a non-canonical form. A b bar c plus ac plus a b c bar. Is this a canonical or a non-canonical form? This is again a non-canonical standard. Why? Because the first term has got all the three variables in it. Either in the standard form or in complemented form, that doesn't matter. Here, every single min term should have all the three variables. Only then it is a canonical form. Here, the first variable has got all the three variables. Whereas check on the second one. Here, which variable is missing? B is missing. So, this equation cannot be called as a canonical form. This is a non-standard canonical form. The last term when you check, this has got all the three elements, so not a problem with this. But even if one single min term, if it doesn't follow the criteria of having all the variables in it, then that expression cannot be called as a canonical form. It is still a non-canonical form. Fine. In this lecture, we'll be studying how to convert a non-canonical form, that is a non-standard canonical form, into a standard canonical form. Understood? I hope now you would have understood what is the difference between a canonical and a non-canonical. This canonical and the non-canonical forms, we'll be using it in both SOP as well as in POS. Whatever terms that I've given you, these are all for SOP. That is, these are all min terms. In a similar way, you can solve it for POS as well. I'll give you a few examples for POS so that you'll be able to understand how to differentiate between canonical form and non-canonical form in POS also. Fine? Tell me whether this is a canonical or a non-canonical form. This is a non-canonical form. Why? Because the max terms, we have got how many max terms here? We have got two max terms. And the max terms doesn't have all the variables in it. Here which variable is missing? Here C is missing. And here which variable is missing? B is missing. So this expression cannot be called as a canonical standard form. This is with respect to POS. Whatever we have seen here, these are with respect to SOP. Understood? As part of this lecture, we will be converting whatever expression that has been given to you. If we get to find out that this is a non-standard form, then we have to convert that into canonical form. And how to convert that, that is what we are going to see it. Fine? And why we have to do this conversion? Why we have to convert a non-canonical standard form into a canonical standard form? That's because while doing the mapping in the K-map we have already seen in the previous lecture. If you have not seen that lecture, I'll give the link of it in the description. You can refer to it. That video has got a complete detailed description of what a K-map is, how to do the mapping, what are the different types of mapping, and how to derive the simplified expression and all. Full detailed video is there. It will be very useful for you if you have a look on it before coming here. Fine. Now, coming back, for mapping the minterms or max terms in the K-map, these minterm or max term has to be in canonical form. If it is the non-canonical form, then you cannot map it in the K-map. Clear? For simplifying any equation using K-map, the first step has to be to convert the non-canonical standard form to a canonical standard form. Clear why we have to do this conversion? Okay, now let's get into the topic. Now let's solve few problems on how to convert a non-canonical standard form into a canonical standard form so that you'll get a better understanding of how this conversion will be doing it. Clear? Your question will be like this. What they've asked you to do, convert the given expression into canonical SOP form. Now tell me whether this is a non-standard form or a standard form. How many variables do you have in this expression? We have got three variables. What are the variables? A, B and C. These are the three variables. You have to check every minterm and see whether all the three variables are included in that minterm or not. Fine? Is all the three variables present in this particular minterm? No. Which variable is missing here? B is missing. In this particular minterm, B is missing. Right? Here, on the second minterm, which variable is missing here? Here, C is missing. And in the last variable, here which variable is missing? A is missing. Right. Okay? Now, your first step has to be, if they are asking you to convert the given expression into canonical SOP form, if they are asking you to convert into SOP form, the missing variables, whatever missing variable is there, that you have to represent like, say, y is equal to a, b plus b bar. You know, a plus a bar is equal to 1 as per the Boolean postulates that we have seen. Fine? And c bar. The first term I am writing here. In the first term, which variable is missing? B. So, in the place of b, I have written it as b plus b bar. You know, b plus b bar is equal to 1. So, a into 1 is going to be a only. So, that is not going to make any difference here. So, whichever missing variable is there, that missing variable you have to represent in this format. For the second minterm, which variable is missing here? C. So, how you will be writing it? AB into, how do you write C? It is C plus C bar. Clear? And coming to the last term. Here, which variable is missing? A is missing. So, I'll write A plus A bar into the remaining term. I'll write it as such. Is it clear? Now, can I do a multiplication here? I'm going to multiply this term with this term. It is AB plus, and then with A, I'm going to multiply the second term. That is AB bar. The entire term into C bar plus. Here again, this entire term I'm going to multiply it with C first. So it will be A, B, C, and then I'm going to multiply it with the second term, which is A, B, C bar. Is it clear? In a similar way. Here, this entire term I'm going to multiply with A first. So it is A, B, C, and then I'm going to multiply it with the second term. That is A bar, B, C. I'm going to multiply C with this entire term. A, B, C bar. Now I'm going to it is A, B bar, C plus the remaining term I'm going to write it as such. It is A, B, C plus A, B, C bar plus A, B, C plus A bar, B, C. Is it clear? Now check here. You also know A plus A is equal to A. This is again one of the postulates. A plus A is equal to A. What does it mean? If you have the same variable twice, then instead of writing that twice, you can write it single time. Fine. Now check in this expression if you have a same minterm repeated twice. Now ABC bar. Are we having ABC bar? Yes. We have ABC bar here. We have two times here. So as per this rule, A plus A equal to A. Rather than having two occurrences of this minterm, can I have it as a single occurrence? So I will be writing it as A, B, C bar. Clear? Now check for the second minterm. Having that here? No. Now check for ABC. Yes, I have ABC here also. There are two occurrences of ABC midterm. So I'll be mentioning that only once. The second term was not present, so the second midterm I'll write as such. The third midterm, it is present in two places, so I'm writing it only once. The fourth midterm, we have already written it here. Now the final midterm, this is going to be my final expression. Here in this expression, if you see, every single midterm has got all the three variables here. What are the variables that we had in this expression? We had A, B and C. Now we have got A, B, C. Whether you have it in actual form or whether you're going to have it in complemented form, that doesn't matter. But that variable has to be there. That is what the criteria is. Here A, B, C. All the three variables are there in this midterm. Here, check on the second midterm. Here again ABC. All the three variable. Here again ABC. Here again ABC. So, that is, in the final expression, whatever you have got, every single midterm in that final expression has got all the three variables that was given in the question. Clear? This is how you will be converting a non-canonical standard form into a canonical standard form. I hope you are clear with how to do the conversion using SOP. Now let's do for POS. Your question will be like this for a POS. Convert the given expression into canonical POS form. Let me take the equation as A plus C, B plus C into A plus B. Fine. Here, whatever expression is given to you, it is a POS form. Why did I say POS? POS meaning it is product of sum terms. These are my sum terms. I have done a product of my sum term. Right? Sum terms are also called the max terms. This is one sum term, this is one sum term, this is one sum term. Sum terms are also called as max terms. Fine. Now, tell me whether this is in standard form or non-standard form. Non-standard in the sense it is non-canonical form. Standard in the sense it is canonical form. Now tell me whether it is in standard or non-standard form. This is in non-standard form. Why did I say? Because how many variables are here? You have got three variables. What are the variables? A, B and C. Right? Check every single max term and see whether you have got all the three variables in every max term. Here, let's take the first max term. A and C is there. Which variable is missing here? B is missing. Now, check on the second max term. Here, which variable is missing? Here, A is missing. And check on the final max term. Here, which variable is missing? C is missing. That is why this equation is called a non-standard canonical form. Your question is to convert this non-standard canonical form into a canonical form. Let's see how to do it. In SOP, whatever is the missing term, how did we represent that missing term? We represented that missing term with A plus A bar. Right? We multiplied that with the minterms. Right? In the case of POS, if you find any missing variable in a max term, then that missing variable you are going to represent it as A dot A bar. Is it clear? Fine. What is A dot A bar? A dot A bar is equal to 0. Clear? Now, let's write the expression. This is as per the Boolean postulate. Fine? Now, give the expression A plus C plus, here which variable is missing? B variable is missing. And B variable, in POS, every single max term is a sum term. So, whatever is the missing variable, that missing variable you have to represent it like this by summing up with the max term. Fine? Now, which variable is missing here in the first term? First max term, it is B. So, I am going to represent B as B into B bar. Clear? Now, this is one max term. Check on the second max term. Which variable is missing here? Variable A is missing. So, how will you represent? It is A bar plus B plus C. Fine? In the third max term, which variable is missing? C is missing. So, how can you write C? It is C bar. Clear? We have a rule like A plus BC is equal to A plus B into A plus C. Right? Whatever is the product term here, you have to expand it like A plus B into A plus C. In a similar way, we have two terms here, two product terms here. So how will you expand this entire term? You can assume it as A. This entire term, if you assume it as A, let me take another variable. This entire term, if you assume it as X plus, this is something like X plus B bar. So how can you expand using the same concept? This is nothing but X plus B into x plus b bar, right? Where x is what? X is a plus c. So this is a plus c plus b into a plus b bar plus c. Understood? Try to give me the expression here. It is a plus b plus c into a plus b bar plus c. Clear? Now, give me in a similar way, give me the expression for the second max term. It is a plus b plus c and a bar plus b plus c. Fine. Now, expand the third max term. It is a plus b plus c into a plus b plus c bar. Clear? Now, you know a dot a is equal to a. We have a Boolean postulate that states a dot a is equal to a. That is, if we have two occurrences of a same variable, then you are going to represent that with a single variable. Clear? Now check for every single max term here. A plus b plus c. Check whether this max term is repeated. Here it is b bar, here it is repeated. And here again it is repeated. 3 times it is repeated. So if there is three occurrence, also it is, we are going to follow the same rule. A dot A dot A, it is going to be only A. Clear? Here 3 times the same max term has been repeated. Since A plus B plus C is been repeated thrice, I am going to write it only once here. Understood? Now, check for the second max term. A plus B bar C. Is this term repeated? No. So let me write this term here. A plus B bar plus C. And this max term we have already written. Check for this max term. A bar plus B plus C. We don't have. So I am going to write A bar plus B plus C. This max term again it has already been included. Now check for this. This max term is also not there. This is again only one time occurrence it is there. So this is going to be my final max term expression. This expression is in canonical POS form. Why am I saying it is in canonical POS form? Because every single max term has got all the three variables. The three variables that we had in the question was A, B and C. When you check on the final expression, every single max term has got all the three variables. Whether it is in actual form or whether it is in complemented form, that doesn't matter. Every single max term should have all the three variables in it. So this is the final canonical POS form. This is how we have converted the non-canonical POS form that was given in the question into a canonical POS form. There is only two rules that you will have to concentrate in this particular logic. If they are giving you any non-canonical standard form, be it POS or SOP, you have to just follow this rule. If it is an SOP, the missing variable has to be represented like A plus A bar. And in case if it is for POS, the missing variable has to be represented as plus A into A. Clear? And you have to take out your final expression, and in the final expression, check whether you have got all the three variables or how many variable is there in the question. The final max term in case of POS or min term in case of SOP should have, every min term should have all the variables that has been given to you in the question. Is it clear? This is the canonical logic form. This is how you will be solving it. Is it clear? I hope you are clear with this concept. If you find this lecture useful and informative, please like, share and subscribe to my channel. Thank you.